welcome. This is a recording to review and finish our dimensional analysis lesson from Wednesday. And so I feel like Wednesday was a little bit rushed because we had that half-day schedule. So I'm going to slow down here in the beginning of the recording. So if you feel comfortable with the lesson we had on Wednesday, maybe fast forward a little bit. I have the screen open, hopefully that you could see the numbers on the left-hand side so you can fast forward to about slide 22 or so. And if you're feeling comfortable with that, which is multi-step dimensional analysis, then you can fast forward a little bit more to the density section. So that's up to you. But again, we're working on what's called dimensional analysis, and we want to be able to solve one-step and two-step dimensional analysis problems. And in order to work with dimensional analysis, basically it's all about multiplying and dividing fractions. And so these were the quick fraction review slides we had the other day. Two things I wanted to point out here up at the top is that when you're multiplying and dividing, order doesn't matter. So I could take 4 times 6, get 24, divided by 2, get 12. I could take 6 divided by 2 and get 3, and then times 4 is 12, and so forth. 4 divided by 2 is 2, 2 times 6 is 12. So order doesn't matter. You just always want to make sure you're multiplying things that appear in the top and dividing anything that appears in the bottom. On the right-hand side, same thing is true when we're dealing with units. So it doesn't matter order, but we can cancel units where we're not going to cancel numbers. Now you could reduce numbers, but we're going to use a calculator to do that work for us. But we are going to have to cancel units by hand because calculators don't do that for us. And so we can cancel units. So again, the second bullet point here, you could reduce or cancel out terms or units vertically and diagonally. So I could say centimeters over centimeters. Let me move to drawing here. Centimeters over centimeters cancels out. And so this answer would just be 2, and there wouldn't be any unit there at all because they would have canceled. In the one at the bottom, you can also cancel diagonally. So centimeters would cancel out with centimeters here, and our answer would have the unit of miles in it. I'm just going to abbreviate there because I'm running out of room because centimeters canceled out. So miles would be the only one left, and then we could grab a calculator. In this case, we could just do it, multiply, divide the numbers to get our answer. We do the units by hand. The reason why we could do that diagonally is because when you're multiplying fractions like this, really, you can put the whole thing on top over the whole thing on bottom instead of keeping them as separate fractions because, again, order doesn't matter. So you're just multiplying everything on the top and dividing everything on the bottom. And so that's why we can cancel out diagonally because it really is one huge fraction. We're writing them as separate pieces. And you'll see why as we move through, because we want to see those conversion factors. We want to be able to apply it to eventually our chemical reactions and so forth. And so we don't want to write them as big fractions, but they are in essence. If I move to the next slide, another, again, example where you can multiply and divide in any order, and just showing you that even though you're multiplying 3 kind of fractions, I guess, sort of say this is really over 1 if there's nothing there. You can also write it like you see on the right-hand side. Really is just one big fraction if you wanted to do it that way. I'm going to skip over this. It's the same idea. And this one here is the one that we had shared in class, again, showing the same ideas with units this time. So on the left-hand side, again, I could go through by hand and deal with the units because my calculator is not going to do that for me. And I could cancel top and bottom, or I could cancel diagonally. And what we're going to be doing mostly in our dimensional analysis work is canceling diagonally. So I could cancel grams with grams because I have a gram on the top and a gram on the bottom. I could cancel milliliters with milliliters, again, because I have milliliters on the top and milliliters on the bottom. And the unit I'm left with is liter. So that is with what my answer is in. Again, the whole idea behind dimensional analysis is converting units. And so this problem here started off as grams, and ended as liters. So by doing the dimensional analysis, we were able to convert or change our units from grams to liters. On the right-hand side, it's the same idea, only it's written as a big fraction just to show that that's what we're really doing. I know in algebra and algebra 2, I'm sure you've seen a lot of variables top bottom where you're canceling things out, x's and y squareds and y's and so forth. Same idea here. Instead of y's and x's, we're dealing with grams and milliliters, units, but the same idea applies. Again, the reason why we could cancel out diagonally is because it really is just one big fraction. And so again, I could do grams cancels with grams on the bottom, milliliters cancels with milliliters on the bottom. And in this case, I changed the unit. I was trying, like I said, to be a little realistic, and again, it's what's going on in my head. You don't have to worry about it. But what's left over this time is grams. And so that would be our answer. In this case, we're not changing units because everything else canceled out, but just showing that we can write it as a big fraction. And so again, that's the idea behind dimensional analysis. We want to be able to convert units. And we're going to start off with something basic that you've probably seen before, so converting between feet and inches and miles and kilometers, and then eventually apply the same concept to go from moles to grams to liters, or some other chemistry conversions, applying it to chemical equations. So in order to do dimensional analysis, in order to convert units, we need conversion factors. And so conversion factors are equivalent values used to change one unit to another. On the right-hand side is an example. A conversion factor is that 1 foot. For every 1 foot, you get 12 inches. So 1 foot is equal to 12 inches. Using that conversion factor, I can convert feet to inches or inches to feet. That's the idea behind a conversion factor. Conversion factors can be written as equalities, as you see here, but also as fractions and ratios. And so for every 1 foot, I have 12 inches this time on the bottom. And I can also flip that around and say for every 12 inches, there's 1 foot. So we're writing them in fraction form. Really, we're writing them in ratios. We can think of it that way. And these are the two ways we're going to be able to plug it into our problems to solve. So although you could write it as an equality, we're not going to be able to plug it into our equations or our work that way. I probably shouldn't say equation because it's not an equation, but we can't plug them in that way. We have to plug them in fraction form. All of every other number or set of equalities you see there in the gray boxes are all conversion factors. So they're separated by length, volume, mass, and you can see that they're converting between what we would say American units, or units we use here in the United States, and the metric system. As I mentioned on Wednesday, we'll take another look at the metric system and we'll review quickly. But the metric system is based on tens. And so in order to change units within the metric system, all you're doing is moving decimals forwards or backwards, right? For the most part. So we're going to practice our dimensional analysis using numbers like this that are not in the metric system so that we can practice the skill. Also, all of these conversion factors have a 1 on one side. So 1 inch is 2.54 centimeters. 1 gallon is equal to 4 quarts, and so forth. So oftentimes you see conversion factors with a 1 on one side, and it makes it a little bit easier to kind of predict where your answer should be, or if you're getting the correct answer, or estimating if you don't have a calculator next to you. And it's just that ratio, that conversion factor, reduced to its smallest form. So usually there's a 1 on one side. As we get into what's called mole ratio eventually down the road, we may not have a 1 all the time, but it is often. So anyway, as you're doing the homework eventually for this gray chart is given so you could use it for your conversion factors. This went really well during class time, so I'm just going to walk through it, but this is identifying a conversion factor. So again, conversion factors have to have 2 units. because the whole idea is to convert units. And so in this first one, if we just have hours, that's not a conversion factor. In the other two, we also only have one unit. Letter C gets close, but doesn't finish, right? Letter B is the only one that's a conversion factor. It's two different units set equal to each other. For every 1 minute, there are 60 seconds. Conversion factor. All right, so this was our first example that we shared. This is converting inches to feet. And so over here on the right-hand side, steps to solve, which, as I said, may or may not be necessary at this point, but we want to get into the habit and practice the setup. It will be really beneficial down the road, trust me. So there's probably a lot of you that could just do this in your head, set it up in your head, especially one-step problems. But when you go to answer, especially in class or even when you're doing your homework, I would get into the habit of writing it out, making sure you're including your units, because it will just get you into the habit of when we have a more complex problem, and even more important to be able to write it down and look at the units. So the steps over here are choose your conversion factor. So because I need to go from inches to feet, I need a conversion factor with inches and feet. And so if this were your homework, you could go up to the chart if you don't know what the conversion factor is between inches and feet, and you can find it within this chart. It's the one down here that I ended up boxing because that's the one that we had shared as an example. But you can find your conversion factors there if you're not sure what they are. And so I chose for every 1 foot, there's 12 inches as my conversion factor. Step 2 is to write what is given, and typically there's only one number given in this type of problem, especially the beginning ones. And so we only have 232 inches, and so that's our given, that's what we start with. And it's really important to write the number and the unit, because if you don't write the unit, then you won't know how to plug in your conversion factor, and then the whole problem could be wrong, especially down the road. So I'm writing 232 inches, including the unit. And now I want to plug in this conversion factor in a way that makes my units cancel. I can't plug it in with that equal sign. But in step 3, it says insert the conversion factor into the problem so that the units cancel and you are left with the unit asked for in the question. Basically, units have to match diagonally in order for them to cancel out. So I'm going to put 1 foot over 12 inches. I can also write 12 inches over 1 foot, right? Because you can write conversion factors 3 different ways, as an equality and as 2 different fractions, one something on the top and something on the bottom. So I'm choosing to put it into the problem this way so that my units cancel. So my inches cancels with inches because they're diagonal to each other. And I'm left with feet as my unit, which is good because that's the question. If I had this flipped around, I would end up with inches times inches over feet, and my answer would be inches squared per foot, which wouldn't make any sense for what we're trying to do. And so units should always match diagonally so they cancel out. Once you are done dealing with the units, then you could just grab your calculator and figure out and solve. So again, that's step 4. Multiply anything that appears in the top and divide anything that appears in the bottom. And I typically just go across the top and then divide each, and you'll see when we get to longer problems what I'm talking about. I divide individually. But again, we're dealing with fractions here, or we're multiplying and dividing, even if it's not fractions. Order doesn't matter. So you could take 232 divided by 12 times 1, 1 divided by 12 times 232. It doesn't matter. In this case, 1's not changing anything. You don't even have to plug it in your calculator. But you should be multiplying everything on the top and dividing everything that appears on the bottom. So in essence, it's 232 times 1 divided by 12. So again, we worked the units by hand. We did the numbers in our calculator. And also one last thing you want to check is number 5. Make sure your answer has the correct number of significant digits. And so one of the rules of significant digits is that conversion factors are not included when you're trying to count significant digits. They technically have an unlimited amount of significant digits. So we only look at the number we're given here. Now, eventually in some more complex problems, you may have some other numbers to look at, but for the most part, for a while, as we're working this, it's going to be that beginning number that you're looking at. So someone took a measurement somewhere of something in inches. I know they measured a wall. I don't know, 232 inches. I don't know. Is that big enough for a wall? I don't know. I guess so. So somewhere someone made that measurement with 3 significant digits, and therefore my answer should also have 3 significant digits. So that's why I wrote 19.3. And again, units are super important moving forward, so you shouldn't just write 19.3. It should be 19.3 feet. Make sure the unit's included. Okay, so that's really it for one-step dimensional analysis. I'm going to flip through a few questions, and as I'm doing that, you can pause if you want to try them. This is one more example that I shared in class. I know having the word mass here was not the best idea, is throwing some of you off, but we have 0.23 ounces and we want to change it to grams. And so again, I went back to that gray chart and I found my conversion factor with ounces and grams in it. I started with what's given in the problem, 0.23 ounces. I plugged in that conversion factor so that units match diagonally and therefore cancel. And I'm left with grams, which is good because that's the question. I've taken care of the units by hand. I could grab my calculator, multiply anything in the top, divide the bottom. 0.23 times 28.35 divided by 1. Of course, you don't have to do the 1. And you get 6.5 grams because we're starting with 2 significant digits. We should end with 2 significant digits, and the units should appear. Right, so here's one. I think we only did one in class, maybe. Let's go to this one, since I think we did that one in class, but we may have looked at this one too, actually. But let's go ahead and pause here if you want to try to work it out. We're changing 15 kilometers to miles. So pause here if you want to give it a try, then I'll flip the slide. Right, so here's the answer. I'm starting again with well, let me back up. I'm choosing my conversion factor with kilometers and miles. In my conversion factor, I went to the gray chart and found it. I'm going to start with what's given in the problem, 15 kilometers, including the unit. I'm plugging in my conversion factor in a way so that units match diagonally and cancel. I'm left with miles, which is good because that's what I'm being asked for. And again, I'm starting with 2 significant digits, so I should end with 2 significant digits. Also, too, we could see here that kilometers are a little bit bigger than miles, so my answer should definitely be smaller than the kilometers I started with. So that can help you eliminate some answer choices, or in all of these problems, you can make a good estimation of where your answer should be probably before you work it out, or when you're done, you can ask yourself, does my answer make sense? And again, kind of take a look at what you're doing, what you're multiplying by, look at that conversion factor, and that could be helpful. All right, so this next slide is where I had said to fast forward to if you felt like you were comfortable with that first part. But recognizing conversion factors and eventually putting them into multi-step problems. So if I wanted to change days to seconds, you could pause the recording here for a second and think through what kind of conversion factors you would need to go from days to seconds. All right, I'm going to go ahead and flip the slide. Here's some conversion factors you'll need. Now, maybe you know how many seconds are in a day, and you could just use one conversion factor. I'm going to say I don't know that off the top of my head, but I know how many seconds are in a minute. I know how many minutes are in an hour, and then I know how many hours are in a day. So I could use 3 conversion factors this time to get me from days to seconds. And so in all of our previous problems, there was a conversion factor available that let you convert in one step. This is a type of problem that we can't, or we don't know what the conversion factor is to be able to convert in one step. So we could use many conversion factors. In this case, 3, we could use 4, we could use 100 if we really had to. You could string together as many conversion factors as you need to in order to convert your units from one to another. So I'm going to go ahead and just flip the slide and use this one as an example. But again, I started with 4 days because that's what was given in the problem. And I started plugging in my conversion factors. I used this one first because, again, you want units to cancel. And it's the only one up there with days, right? So I need to use that one and cancel out my day. And we're only going to use each conversion factor once. So now we're done with that one. Now I need to plug in another conversion factor to get rid of hours. And so this middle one is the only one that has hours that's left that we haven't used yet. So that goes next. And again, units should match and cancel out diagonally. So hours with hours cancels. I want to get to seconds, so I need to use that last conversion factor. It's the only one we have left. And I'm going to plug that one in last. And again, making sure units cancel. So minutes cancels with minutes. I'm left with seconds, which is good because that's the question. And again, I'm going to go ahead and grab my calculator, multiply everything across the top. So 4 times 24 times 60 times 60, and then divide everything in the bottom. So divided by 1, divided by 1, divided by 1, which of course we don't have to do, but eventually those all won't be 1, so we will. And that's our answer. So we only need one significant digit because we only started with 1. So I've rounded the answer to show only one significant digit. Those zeros don't count. Or better yet, writing it into scientific notation so that you're not showing all of those zeros and only showing your one significant digit. And again, making sure seconds are there as well. Right. So here's one for you to try. Similar. This time you're going from seconds to days. You're using those same 3 conversion factors. And so pause the recording here and see if you could string them together correctly and end up with the answer. Okay. I'm going to go ahead and flip the slide. Again, I'm starting with what's given in the problem, making sure I'm including my units. I've plugged in my 3 conversion factors in a way to make units cancel. So seconds cancels with seconds because they're diagonal to each other. Minutes cancels with minutes, diagonal to each other. And hours cancels with hours. In order to get this to happen, there's only one way that you could string those together using them one time each. So as long as you continuously make sure units are matching diagonally and canceling out, you should be okay. This also, again, then you grab your calculator, multiply, divide. And this is a way for me to show you what I like to do. So you would have to take 100, or 1, 2, 3, 4, 5, 6. 123,456. And you would have to divide it and use parentheses around the bottom. You could divide it by parentheses 60 times 60 times 24. Or what I like to do in my calculator, which I think might be, I don't know if it's the lazy way, but I typically try not to use parentheses because I just don't want to have to keep hitting that button. So what I do on my calculator is I take 1, 2, 3, 4, 5, 6, divided by 60, enter, divided by 60, enter, divided by 24, enter. So I just divide each number separately and hit enter every time, so I don't have to worry about the parentheses, but that's up to you. You're multiplying everything in the top and dividing everything in the bottom. Make sure if you don't use parentheses and you don't do what I just said, then your calculator is going to pull those numbers back up to the top and multiply instead of divide. So you want to be careful. I started off with 6 significant digits, so I ended with 6 significant digits. Alrighty, so 2 quick polling questions just to kind of check in. So here's the first one. Can you find out or take a look and see what's wrong with the setup here, changing inches into kilometers? So pause the recording here, you could take a look. right? So if I take a look here with my units, the kilometers are canceling out. But then if I take a look at the rest, I have miles and miles on the top and nothing on the bottom. So that would be miles squared. The feet do cancel out. So we have feet and feet here. But then inches at the bottom don't. So my answer is going to be miles squared per inch. And we want to figure out how many inches there are, not miles squared per inch. And so the units are not canceling diagonally or not canceling at all. So the ratio of feet to inches is not correct. No, that's good. 1 foot is 12 inches. The conversion factors don't all have 1 on the same side of the division bar. That doesn't matter, right? So you can flip the conversion factors around however you need to make it work. You can't divide small numbers like 1 by large numbers like 5,280, which of course doesn't make sense. But letter D, the miles don't get canceled by the second conversion factor. And also inches are left on the bottom where we want that to be our answer at the top. Alrighty, one more quick polling question. Here's this one. So choose the answer that is true about the above calculation. Could pause the recording here. Okay. And so I will tell you that it depends on how you're looking at this because of the answer that I put in here in letter A. The answer is 108 inches, but by significant digit terms, that wouldn't be correct. So I'm going to change this beginning number here to 3.00. So we have 3 significant digits. Oops, my slide changed. 3 significant digits to start so that the answer works out to only 1 answer. But anyway, that won't change, right? So the zeros aren't going to change our answer. So with those 3 significant digits, now we could say that yes, the answer is 108. Yes, 12 inches is 1 foot. Yes, all the units cancel out except for inches. So therefore, all the above are correct. So again, I just had to change that here to match the 108. So we can have starting 3 significant digits and ending 3 significant digits. All right. So here is where we were going to do some practice. You could try it now if you'd like. Maybe I'll do this one together in class, or we can do this one or a different one that's similar when we get back. I don't know if I did that. I guess I made that circle there somehow. But anyway, you could pause the recording here and give these a try, and then I'll flip to the next slide, or these will be posted in the course tomorrow morning, and so you could take a look then if you'd like to. So pause the recording here if you want to give these a try. The third one is the challenge one, so that's up to you. Here's our answer. So you could, again, pause here and take a look if you'd like. I'm going to skip over the next 2 slides. That's additional practice we could do when we're back together. Okay, I'm going to flip here next. So this is just, now we're not going to do too much of this, especially in this unit that we're currently in. But if you want to, you can convert 2 units at once. So in this particular case, I'm just sharing this with you so you've seen it. We're starting with kilometers per hour. So we're starting with 2 units, not just one given number. They're giving us kind of 2 given numbers, sort of say, or 2 units. And so you could do both, right? You could do both at the same time. You just want to make sure you're plugging in your conversion factors in a way that makes your units get to where you want. And because order doesn't matter when you're multiplying and dividing, you could put the conversion factors in any order you want. So in this case, I worked with kilometers first and made sure they canceled out, and I had miles on the top. And then I used a conversion factor to get from hours to minutes. And so again, now the hours canceled out. And so I'm left with orange, I guess. I don't know if you'll see orange. I guess I'll use orange. We're left with miles per minute, which is what we wanted. So again, just doing 2 units at once. you can do that too. Okay, so here's an example if you wanted to try converting 2 units at once. Again, we're not going to be doing too much of this, but if you'd like to give that one a try, you could pause the recording here. Great, so I'm going to flip the slide. Here's a look at the answer. So miles are canceling here. Minutes are canceling here. Again, order doesn't matter. You just want to make sure eventually that they're canceling. And there's your answer. Alrighty, so that is it for 1-step and 2-step dimensional analysis. That is about 30 minutes. So I'm going to keep going a little bit, but we're going to pick up with this when we get back together so that you can do all of the homeworks that are there tomorrow if you want to. And so we're going to use density as a conversion factor and do a lab where we could practice measuring and significant digits and dimensional analysis, all this stuff together at once. Get back to our graphs and our slopes and being able to answer our questions that way to get us back into our swing of things with our calculations and math and labs. So anyway, density, if you remember, I'm sure you've seen it before, is a measurement that compares the amount of matter an object has to its volume. So density, letter D, is equal to mass per volume. Over here on the left-hand side, this is an image from Gizmos, which by the way, I don't think I mentioned it in class the other day because we didn't get too far, but it is posted in the course that I do have a Gizmos available to you. Again, you could get to Gizmos through ClassLink, and there is a dimensional analysis Gizmo available if you wanted to go in there and continue to practice dimensional analysis. Anyway, so on the left-hand side, the density of the liquid in the beaker is 2.5 grams per milliliter. Because the ball is floating, the density must be less than that, right? So the more dense an object is, I guess relatively speaking, the more it's going to sink, right? In the beaker on the right-hand side, the density of the liquid is 0.5. And so the density of that circle there must be greater than 0.5 because it's sunk to the bottom. On the right-hand side is probably something you've done at some point through your schooling in grade school or middle school, density column. So you could see that those liquids are separating out because they have different densities, and vegetable oil down to honey there. Right, so density is mass per volume. This here is just an example of a problem where you're calculating. So you're basically just dividing. So it says a cube of ruthenium metal has a volume of 3.375 cubic centimeters, a mass of 42 grams. What's the density? And so again, all you have to do, density is mass per volume. So you take the mass divided by volume, and your answer should have both units, mass per volume, because again, that's what density is. And then it's asking, will that metal float on water? The density of water is 1 gram per cubic centimeter. And so the answer is no. That's clearly a larger density than 1. So if you put this metal into a glass of water, it would sink to the bottom. Right, so here's one for you to try, maybe. I feel like when I flip the slide, the answer is already there. So I could try to cover it up really quick. I don't know if I'm going to be able to. So let me see. We'll see if it works. So close your eyes. I'm about to flip the slide. That wasn't fast, was it? Anyway, it's blocked now. So you can take a look, see if you can calculate density. Again, density is mass per volume. Right, so I'm going to take that block back off that I just put on there. Then you can see the answer. So you just take the mass divided by the volume. You can, again, make sure we're paying attention to significant digits. Your answer should be grams per milliliter in this case, because those are the units that were given to us. And again, copper is not going to float on water because density of water is 1, and this is 8.9. All right, so that is just a review of density, what density is. We're going to use density as a conversion factor because density has 2 units, mass and volume. And so because it has those 2 units, It could be used as a conversion factor. And so here's a look at two examples of using density as a conversion factor. So in this top one, we want to find mass. So it says, what is the weight of ethyl alcohol that exactly fills a 200 milliliter container? That's not working. There we go. A 200 milliliter container. The density of ethyl alcohol is 0.789 grams per milliliter. And so again, you want to start with what's given in the problem. So we're given the conversion factor. That's not what we want to start with. So you don't start the problem with the conversion factor. I'm going to start the problem with what was measured. So 200 milliliters. That's my first number. And then I want to plug in the conversion factor, which is our density, so that units cancel. So it's 0.789 grams per milliliter. I could plug it in that way because units are going to, I wonder why that keeps doing that to me. Because units are going to cancel that way, right? And so if you're reading this as grams per milliliter, that means grams for every 1 milliliter. So we typically don't write ones in chemistry or in a lot of math places like here. And so when you go to write it into your problem, you could write the 1 so that it looks nice. We know what that is. And so again, units cancel diagonally, multiply, divide, you get your answer. There really should be one more digit there. Maybe the calculator just made it equal. I'm not sure. At the bottom is another example. So this time we have a mass given to us of 2,500 grams. They're giving us the density. And so again, we want to find volume. So this time when we go to plug it into the problem, we need to flip it around. Oops. What did oh, it got shifted. It just got shifted in the, I wonder if I could change it. But anyway, the density is 10.5 grams per cubic centimeter. And so this time I need to flip it around because I need grams to cancel. So I'm going to put that 10.5 grams on the bottom per every 1 cubic centimeter. Again, they're not writing the 1, multiply, divide, and get your answer. I wonder, I'm going to try this. Let me see. Yeah. So in these answers, there should be the same number of significant digits that you're starting with. So the one at the top should have 4, the one at the bottom should have 5. So that really should be carried out a little bit further. Right, so again, using density as a conversion factor. Here's a practice one. You could pause the recording and give it a try if you'd like. I'm going to go ahead and flip the slide. Okay, next up, so one more. Great. I'm going to go ahead and flip the slide here. Both of those were good if I flip back, so not like the example ones that I had above. This started with 2 significant digits and ended with 2. This one started with 1 significant digit and ended with 1. All right. This is just a slide I threw in here for review. So if you've had geometry, or maybe even if you haven't, I'm sure you've done volume calculations at some point in your math career. The volume of a cube is length times width times height. So if you have a shape that is normal, I guess, sort of say like a cube or a rectangular prism, you could use the volume equation to find volume. And so in a density problem like this, it says a company makes concrete bricks that are shaped like rectangular prisms. Each brick is 6 inches long, 6 inches wide, 3 inches tall. What is the volume of each brick? So in this case, you could just multiply all 3. And again, volume should always be a cubic number, so cubic inches. Another way so again, this only works if you have a cube or rectangular prism, or with different equations, you can find pyramids or cylinders or spheres, right? But it has to be that perfect shape to be able to use those equations to find volume. if you have an irregular shape, like we often do in chemistry, in this case, there's a rock example, we could use water displacement to find volume. So again, we're going back to density. I'm going to get back there in a second, but as part of density, we need volume. And so if we're in lab and we're doing a lab, to find density, we would take the mass of something, throw it on a scale, get the mass. But then we need to find the volume of that something. And if it's not a perfect shape where we could use an equation to find the volume, we would have to use something like this, water displacement, to find the volume, and then we can find the density from there. And so water displacement is just about subtracting. So you would read the graduated cylinder where the water started, throw the rock in there, and the water is going to rise, just like when you sit in a bathtub, the water goes up. And then you just subtract those two numbers, and the difference is going to be the volume of the rock. It's whatever water it displaced. And so anyway, the volume in this case would be 180 milliliters minus the 150 where it started. So I'm estimating there those numbers and then subtract. So the water displacement, the volume then of the rock would be 30 milliliters. Okay, so I believe there's a few density problems in some of the homeworks. I changed the due date to Friday so that we could go over some of this. If you're feeling comfortable with all of this, you could go ahead and give it a try. That's up to you. The other two things I have left here was just reviewing metric units. Here you can see those two slides on the left. This last slide here is letting you know about the gizmos that's available. So again, gizmos is in ClassLink. This is what it looks like. When you click on it, you should be able to get into, you should see it right there on your main screen, dimensional analysis gizmo, and you could go through it and practice any kind of dimensional analysis. Here right now it's on density, but if you click this down arrow, you have choices that you could choose from. You're just going to pull these tiles down to the bottom in a way that they match up and you get the answer that you want to. You could flip the tiles around again so that units cancel. After you submit it, it gives you the right answer, and then you could try another one. Right? So anyway, this and up here is metric units, or you could change it over to mixed units, was probably a better bet to practice, and that is it. So let's see what I have here. So we have the C homework, which is measurement and density together, and then the D homework, which is dimensional analysis. And again, I believe I changed the due dates, so I'll double check on that. But tomorrow when I'm not there, if you could listen to this recording and then try those homeworks if you're feeling comfortable, and I'll see you back on Friday. Have a great day, everyone.